guys, this is Mrs. Millsap, and in this chem tutorial, we're going to be talking about electron configuration. This is 4.4, and I just finished eating a Halloween cookie. Actually, I lied. I just finished eating 2 Halloween cookies, and I also just realized I was looking at the wrong camera the entire time. So if I was looking like awkwardly off into space, I thought that was the camera, but then I realized it wasn't. So in our last video, we learned about orbital notation, which is this lovely thing right here. And orbital notation is essentially drawing where the electrons are going to be inside of an atom. Okay. The big numbers, remember, those refer to the energy levels, and then the letters refer to the shape or the orbital that the electron's spinning in. Okay. So it'd be annoying if we had to write down the orbital notation for every element and had to draw boxes and arrows all the time. So electron configuration is basically a way of writing orbital notation without the arrows, okay? And so instead of using arrows, we're going to use numbers. So if this is the orbital notation for oxygen, the electron configuration for oxygen would look something like this. We would write 1s. Do you see how there's 2 electrons spinning in the 1s orbital? We're going to write down 2 as a superscript, okay? And that 2 stands for the number of electrons. Okay, and then we would write a 2s, and how many electrons are spinning in that? 2. So we'd write another 2 here. And then we move on, we write 2p, and how many total electrons are spinning in the p? Well, there's 2 here, 1 here, and 1 here, so there's a total of 4. So I would write 4 here. That's the total number of electrons that are spinning in the p orbital. Okay, so this is an example of electron configuration. So let's practice a little bit, shall we? Move on right over here to this awesome diagram. This diagram gives you kind of a visual of what it should look like. So these boxes here represent the 1s, this represents 2s, this represents 2p, and then this represents 3s. So hydrogen, you can see, only has 1 arrow in the 1s, so we write it as 1s1. Carbon, on the other hand, has 2 electrons in the 1s, so we write 1s2. And then it has 2 electrons spinning in the 2s, so we write 2s2. And then it has only 2 electrons in the p orbitals, so we only write 2 here. Okay. And as you can see, the number keeps going up as we keep adding electrons. And an easy way to tell if you're like maybe doing it right is if you add together all of the superscripts, the number of electrons, the total number of electrons in the whole atom, which should be the same as the proton number, right? Because we're always assuming it's neutral, so it should be the same as the proton, which is the same as the atomic number. So 2 plus 2 plus 2 obviously equals 6 electrons, right? And carbon's atomic number is 6. So it's kind of an awesome way to check yourself before you wreck yourself. Okay, so moving on, I want to show you guys a really cool shortcut to our shortcut. When you're writing electron configurations, the periodic table is super cool, and it's actually completely set up in such a way that you can like read the periodic table like a book, and you can figure out the electron configuration for any element just by looking at your periodic table. So at this time, go ahead and get out the periodic table that I gave you guys in class. And I know yours is blank, so we are going to label and color it. So if you have like colored pencils or markers available, go ahead and get those out and ready. You are going to need 4 colors. So here's your periodic table, and I know yours has numbers up here. It has like 1, 2, and then this is like 3 to 14. And then it goes 15, 16, 17, whatever, and all the way to 18, okay? Okay, so what's cool about the periodic table is if you look at hydrogen's full electron configuration is just 1s1 because it has 1 electron. If I took you over here and I said, okay, I want you to look at bromine's electron configuration. Bromine has an atomic number of 35, and so it has 35 electrons. And if we wrote the entire configuration for bromine, it would end with 4p5. And what is so cool about that is that your periodic table is specifically set up in such a way that you can
know that it ends in 4p5 just by looking at it. Okay, so here's how we would know that. Well, on the left side, I don't know if this is on your periodic table or not, but if it's not, I want you to write down numbers. I want you to write down numbers for each row. These rows are going to be your periods. Okay, so we're going to write 1, 2, 4, 5, 6, and 7, and then down here we're going to write 6, and then we're going to write 7 on your periodic table. Okay, so these periods stand for the energy levels of the last electrons. So bromine is right here, and guess what? It is on the, all the way over, it's on the 4th energy level. And remember I told you the last part of its electron configuration was 4p5? Well, we would know that because bromine's right here, right? And then it is in the 4th energy level. So we're going to go ahead and block off the periodic table, okay? So everything in the first and the second column. So everything in here, I want you to color one color. And then above it, what I want you to do is label it S. Anything in group 1 or group 2 is, we're going to call it the S block. Anything in group 3 to 14, we're going to call this the D block, okay? And my D block is already labeled green, but just color it a different color, okay? And then everything in from groups 5 to 18, so in that place that I'm highlighting pink, everything in this area, I want you to color another color, okay? And then everything in this area, and again, I'm just the worst at like coloring, so just, I hugely apologize that it's awful. But everything in this group is going to be, is the P block. And then down here, everything in these two groups, this is going to be called the F block. And so I want you to color the F block a different color as well. Okay, so now that you've labeled your S, P, D, and F blocks, and we've labeled our periods, our energy levels, we now know why bromine's last electron configuration was 4 and why it was P. Because see how it's in the P block? That's why it was P. Now, where did I get the 5 from? Where did I get this 5 from? Okay, so we're going to label each row of the P block, 1 through 5. Bromine is in the 5th row, which means it's the 5th electron. So I see it's 4p5. And the way I knew that is because it was in the 4th energy level, it was in the P block, and it's in the 5th row of the P block. 5th row of the P block. So I know it's 4p5 is the last electron configuration. So how would I write the rest of it? Since I'm starting at 4p5, I can read everything before it and see the configuration. So I start here, I'm going to read left to right. So 1s, and bromine fills all the way up, all the way up to 1s2. So I'm going to go ahead and write out 1s2. Then it fills up the 2s2, and then I keep reading, and it fills up the 2p all the way to the 6. Then I keep reading, just like a book, and it fills up 3s2, and then I keep reading 3p6, and then I keep going 4s2, and then notice here that I'm not in the 4s anymore, I'm in the 3ds. That's because on your periodic table, it's going to change energy levels from the 4 to the 3. So on your periodic table, I want you to write 3 right here so that we know this is the 3ds, okay? And then also down below, this is the 4ds. So you always fill up the 3ds before you fill up the 4p's, okay? And so on this other side, I want you to label that we go back to the 4th energy level after you fill up the 3ds. And same thing down here, we go back to the 5th energy level after we fill up the 4ds, we go to the 5p's, okay? And so then this is 6, and then down here this is 7 as well. So make sure you label those on your periodic table. So we fill up, where was I? We are filling up the, we just filled up the 4s's, 4s2, and then I can fill up all of the 3ds, so I'd write 3d10. And then I fill up almost all of the 4p's, and I stop at 4p5 because that's where my element is. Okay, so here's a different periodic table, and instead of writing each individual, like 1s1, 1s2 out, I just showed you which rows were the 4p's, the 2p's, or whatever, but this is still our P block, okay? This is still our D block. This is the S block, and then this is the F block. is all the way down here. So I know it's going to end in the D block, and this is the 4th energy level right here. So I know it's going to end in 4D. So let's start at the beginning. We read the periodic table like a book. It starts at 1s, and remember we kind of pretend that helium is right over here because it's also in the S block. So this is 1s2, and then it fills up the 2s2s next. And then if I go all the way across, it fills up the 2p's all the way to 6, so 2p6. And then it fills up the 3s's, so 3s2. Then it fills up the 3p's all the way to 6, so 3p6. Then it fills up the 4s's, so 4s2. Then it fills, notice again, you have to remember that you drop down to the 3. So it fills up all the 3Ds, so 3D10. And then I go to the 4Ps, so 4P6. And then I go to the 5S's, so 5S2. And then again, I'm at the 4s, remember, because the D's always drop down. So it's 4D, and I stop at 1, 2. I stop at the second column, so it's 4D2. 4D2. And then now I know I'm done with my electronic configuration. Okay, if we do one more, if we do terbium, number 65, so it's located in the F block. So how would we read this? Well, let's pretend that we are starting at zirconium where we started last time. Let's say we just continue writing. We would write 4D10. So I'm going to put dot, dot, dot. Let's pretend we wrote everything else before this. So we're at 4D10 here, okay? And we keep writing. And now, remember, we're at the 5s. Sorry, I forgot to put these here. So we're at 5Ps. So this is the 5P6. And then what row are we on next? Now we're on row 6. So this is 6S. And then if I go next, now I'm at 5D1. And then there's this line. Okay, so I'm going to write 5D1 here. And then this line is going to drop down. And so before I can go to HF, I have to next go to my Fs. And we're going to label this to be 4F and 5F. Okay, so the 4Fs, there's 1, 2, 3, 4, 5, 6, 7, and 8. So it stops at 4F8.
Okay, the last thing we're going to learn in this video is how to write it shorthand. So writing out the electron configuration for an element can be really, really long. So there is a way that we can shorten that. And that is if we look at the noble gas, and these are the noble gases. Noble gases are anything in group 18. Think of each of the noble gases here as being checkpoints, okay? So once we reach a checkpoint, you don't have to do anything that happened before that checkpoint. So what was the save the game that happened right before sulfur? Well, if we go all the way back, neon was the save the game point for sulfur. So what I'm going to do now is I'm just going to write down neon in brackets. I'm going to put a bracket. I'm going to put NE for neon. And then all I have to do is I have to write down the electron configuration from neon to sulfur. So just from the save the date point, or not save the date, saving the game point until sulfur. So I would have to write down, I'm starting here, this is at energy level 3, so it's 3, and then this is the S block, so 3S2, because it's filled all of the S, and then this is the 3Ps, okay, so I'm at 3P, and I do 1, 2, 3, 4, I'm at 3P4. So that is how you do shorthand. So let's do a couple more examples. Okay, write the shorthand configuration for strontium. So strontium is right here. It's number 38. So what was the noble gas that came right before it? Well, if I go backwards, this krypton is the noble gas that came right before strontium. So I'm going to write krypton here. And then I'm going to write the electron configuration from krypton to strontium. So we are now in the 5th energy level. So it's 5, and we're in the S block. So it's 5s2. Rubidium would be 5s1, but strontium is the second box in the S, so it's a 5s2. And that's how we write shorthand. And that is it for today, guys. way to go. You were done with like one of the hardest things ever, and I'm just so proud of y'all. Way to go. Give yourself a little pat on the back for finishing this video.